Here, in this chapter, we are going to study about the area and the volume of a sphere and the area and the volume of the objects related to the sphere. Now, why should we study about this? Many things that we come across in our daily lives are related to sphere in some form or the other. Example, a marble, a football, a cricket ball, a basketball, or maybe even a cheese ball. So to know the area and the volume of these objects is of practical importance. Now, how to find the area and volume of these objects? For a sphere, the volume can be obtained by 4 by 3 pi r cube and the area will be 4 pi r square. There are certain other objects related to the sphere, so we have some formulae in this topic. Let's go through them. We've already seen for a sphere, the volume is 4 upon 3 pi r cube, where r is the radius of the sphere. The surface area is 4 pi r square. Now, if we have a hemisphere, what is a hemisphere? A sphere which is cut into two equal halves is called a hemisphere. So, the volume of the hemisphere is half the volume of the sphere. That will give us 2 upon 3 pi r cube. The surface area for a hemisphere will be 2 pi r square. Now, if we take a spherical shell, a spherical shell is the solid enclosed between two concentric circles. You can imagine any kind of ring that is a spherical shell. For this, the volume will be given as outer volume minus inner volume. Let us have the outer and the inner radii as capital R and small r. Then the volume for the spherical shell will be given as 4 upon 3 pi capital R cube minus small r cube. Now the surface area will be the internal area plus the external area. That will be 4 pi small r square plus 4 pi capital R square. Now 4 pi common in the bracket r square plus r square. Now if we take a hemispherical shell, that is half of the spherical shell, then in that case the volume will be 2 upon 3 pi capital R cube minus small r cube. Now this curved surface area over here will be the internal area plus the external area, that is 2 pi small r square plus 2 pi capital R square. 2 pi common in the bracket r square plus r square. Now we have the last one, that's the total surface area for a hemispherical shell. That will be internal area plus external area plus area of the base. Now internal plus external gives us the curved surface area, which we have already got in the above formula. Now what is area of the base? It will be pi capital R square minus small r square. So the total surface area will be 2 pi bracket r square plus r square plus pi into r square minus r square. We simplify this to get pi common, 3r square plus r square. Now the prerequisites for this topic are, you need to remember the formula of circle and the cone, which we have already done earlier. Now let's take the problems for this topic. The first one, a solid rectangular block of metal 49 centimeter by 44 centimeter by 18 centimeter is melted and formed into a solid sphere. Calculate the radius of the sphere. Now in this case, we are given a solid rectangular block, that is a cuboid, and we are given its dimensions. Now we are told this block is melted and cast into a sphere, and the dimensions for the sphere we need to find out, because for a sphere the dimension is just the radius. So here the metal block is being converted to a sphere, so the volume of the cuboid will be equal to the volume of the sphere. Now volume of a cuboid is length into breadth into height, and volume of a sphere is 4 upon 3 pi r cube, where r is the radius of the sphere. So we start the solution as, let r be the radius of the sphere and volume of the cuboid is equal to volume of the sphere, that is length into breadth into height is equal to 4 upon 3 pi r cube. Now substitute the values. 49 into 44 into 18 equals 4 upon 3 into 22 upon 7 into r cube. Now keep r cube on one side and take all the other numbers to the other side. We have r cube is equal to 49 into 44 into 18 into 3 into 7 upon 4 into 22. Now we simplify all this and we get r cube is equal to 7 square into 3 square into 3 into 7. That is, r cube is equal to 7 cube into 3 cube. So r will be cube root of this. We get 7 into 3, that is nothing but 21. So r is equal to 21 centimeter, that is the radius of the sphere is 21 centimeter. Now let's look at our next problem. A hollow sphere of internal and external radii 2 cm and 4 cm respectively is melted into a cone of base radius 4 cm. Find the height and the slant height of the cone. Now in this case, we are given a sphere which is converted to a cone. So again over here, the volume of the sphere is equal to volume of the cone. Now we are given internal radius for the sphere, let it be small r, that is 2 cm, and the external radius capital R is given as 4 cm. Now for the cone, we are given the radius, say R1, as 4 cm. We are asked to find the height h and the slant height L of the cone. Now we have volume of the hollow sphere is equal to volume of the cone. Now what is the volume of the hollow sphere? 4 upon 3 pi capital R cube minus small r cube. That will be equal to volume of the cone, that is 1 upon 3 pi r square h. So we write that down. Now we cancel 3 from both the sides and also pi. We have 4 into, now in place of capital R we substitute 4, in place of small r we have 2, and in place of the radius of the cone we have 4. So substitute that to get 4 into 4 cube minus 2 cube is equal to 4 square into h. Now we simplify this. 4 into 64 minus 8 is equal to 16h. Take all the terms on one side. H is equal to 4 into 56 upon 16. So h is equal to 14 centimeter. That is, we have got the height of the cone as 14 centimeter. Now we know the height of the cone and we also know the radius of the cone. Using these two things, we can find out the slant height of the cone. L is equal to root h square plus r square by its formula. Substitute, we have root 14 square plus 4 square, which is equal to root 196 plus 16. That gives us root 212. Now we need to factorize this further. We can write this as root 4 into 53. Now since 4 is in the root sign, we remove that outside and get 2 root 53. So we've got the slant height L as 2 root 53 centimeter. Now let's look at our next problem. Here we have a hollow copper ball with external diameter of 12 centimeter and thickness of 0.3 centimeter. Find the outer surface area of the ball and also find the weight of the ball if 1 centimeter cube of copper weighs 5 grams. We are told to take pi as 3.14. Now in this sum, we are given for the copper ball the external diameter as 12 centimeter. So the external radius will be half of that is 6 centimeter. And the thickness is given as 0.3 centimeter. So using that, we can find the internal radius. That will be the external radius minus thickness of the ball, which will be 6 minus 0.3, that is 5.7 centimeter. Now in this, we were asked to find the outer surface area of the ball. That will be 4 pi r square, which is equal to 4 into 3.14 into 6 into 6. We are taking pi as 3.14 because that's given to us. On simplification, we get this as 452.16 centimeter square. Now in the second part of the sum, we are told to find the weight if 1 centimeter cube of copper weighs 5 grams. Now to find the weight, what should we find out first? We'll obviously find out the volume. If you're confused here, you can also find out from 1 centimeter cube of copper weighs 5 grams. So centimeter cube is given. So obviously we need to find the volume. So let's find out the volume of the copper ball. Since it's hollow or it's spherical, we will have the volume as 4 by 3 pi capital R cube minus small r cube. Now substitute the values. We have 4 upon 3 into 3.14 into 6 cube minus 5.7 cube. Simplify this further. We have 4 by 3 into 3.14. Now what is 6 cube? It's 216. And what is 5.7 cube? It is 185.193. Now it's better to look for this value from the log tables. Now we first simplify the bracket. We have in the bracket 30.807. So we've got 12.56 upon 3 into 30.807. Simplify this further. We have 12.56 into 10.269. Multiply these two numbers to get 128.97864. So this is the volume of the copper ball. But we are asked to find the weight. So weight will be volume into 1 centimeter cube weighs 5 grams. So many centimeter cube will weigh how many grams? So we will do the volume into 5. That gives us 644.8932 grams. So the weight will be this. Now we move on to the next problem. Here we are given some lead spheres. Lead spheres of diameter 6 cm are dropped into a beaker containing some water and are fully submerged. Now the diameter of the beaker is 18 cm. Find how many lead spheres have been dropped in it if the water rises by 40 cm. Now here we are told that the water rises by 40 centimeter. So first of all, we have a beaker. Generally, a beaker is taken as a cylindrical beaker. Now in this beaker, lead spheres are being dropped. Now we are given that the water rises by 40 centimeter. So originally, there was some water in the beaker. When we put these lead spheres, the water rises by 40 centimeter. So we will take the rise in the water level as the height, that is h is equal to 40 centimeter. We have the diameter of the beaker as 18 centimeter. So the radius will be half of that, that is 9 centimeter. Now for the lead spheres, we are given the radius as half of the diameter, that is half of 6, that will be 3 centimeter. Now, number of marbles or number of lead spheres that are dropped in the beaker will be equal to the volume of the beaker upon volume of one lead sphere. Now, what is the volume of the beaker? It is cylindrical in shape, so its volume will be pi r square h, and the volume of the lead sphere will be 4 by 3 pi r cube. So substitute the values of radius and the height respectively. We have pi and pi cancels. We have 9 square into 40 upon 4 upon 3 into 3 cube. Now that 4 upon 3, that 3 is the denominator of the denominator, can go to the numerator. Now we simplify this further and we will have 90 marbles. So the number of marbles or the lead spheres that are put in the vessel are 90.